I want to walk you through a scenario why most software applications eventually end up reaching for something called a queue and how it can help your software become more scalable and also a little bit more reliable. So imagine you have an API over here and you have a use case where a user needs to basically upload a video. So let's just go ahead and make a video here. And the video is going to be, maybe it's like a 4K video. It's a very large video and the user needs to have it split up into different formats. So what do I mean by that? So imagine you have a 4K video, and when a user uploads it to your API, you need to split it up into 1080p, you need to split it into 720p, and then also 420p. I'll keep that out of the diagram to keep it simple. But doing this type of work, typically you can use FFmpeg, which can use a lot of CPU and a lot of memory. And so if you just allow a user to upload a giant video to your API, that internally could kick off different processes. And it's going to run FFmpeg to do the transcoding from 4K to 1080p or 4K to 720p. And eventually you're going to get a contention on the box because it's just too much CPU and memory to do all this processing on the same VM. Okay. So one approach that you can do is instead of having one API handle this traffic or having to scale this API horizontally or even vertically, you could actually just bring in something called a queue. Now, a queue is a type of pattern that we can use in software, and often, RabbitMQ provides queues, ActiveMQ, Redis has queues, Kafka is another way to do message and message broking. The keyword is message broker, and the message broker provides something called a queue. It's a primitive that allows you to, instead of the API doing all this work inside of it, it's actually going to do this work somewhere else. It wants to defer the work, do it in an asynchronous worker, and then later on we can notify the user when it's done. So taking a step back, instead of the API doing all the work, it actually is going to emit or in-queue an event into the queue. And this thing could have maybe a file ID, or I could say video ID, ABC123, so that later on, we can figure out where exactly we need to fetch the original 4K video. Okay, now if I want to be proper with this diagram, I should probably have like an S3 bucket, because let's be honest, if you're going to be storing media, you're probably going to use AWS S3 or R2. So you may have an S3 bucket like this, and it's going to instead upload the video from the user's browser directly to S3. And then technically you could have that S3 bucket send an event to the queue when it gets a new file uploaded to it, or you can have it, signal your API. The API could then send the event. It's up to you and what you want to design. But overall, the idea is that you're sending off events now. You're not doing the work inside the API. The API is just basically processing metadata. Maybe you'll have a database that stores, information about the job that was uploaded. So the Postgres database could just store the metadata related to the video, like, okay, what user was it? What's the file name of the video? What's the video ID? But the actual file is going to live in S3. But the thing I'm trying to get at is that the work is done elsewhere. Okay, so typically what's done is you'll have these workers that live somewhere else, and you can get these deployed behind some type of like auto scaling group, or you can use Fargate to automatically scale them up based on something called like the queue depth, which maybe I'll talk about in a second. But the benefit of having a queue is now you can actually have tons of users send in tons of messages all at the same time, and you can have these things basically just queue up, right? They can just get entered into the queue, and when your workers are ready, they can start pulling messages and start processing this event. Okay, so in this particular case, the worker may get the event. It's going to be like, okay, video ID 123, let's grab the metadata. And then it's also going to be like, okay, let's grab the file now. And then it could start processing on that file. It could then probably re-upload, the 1080p transcription back to S3, the 1080p, and then that will basically send back a confirmation to the message broker saying, hey, this message is done, and that event kind of goes away. Okay. Now, right now in this simple scenario, the fact that you have all these messages that get queued up allows many users to try to kick off jobs. And even though you don't have enough workers to process the jobs, they are not going to get a stuck UI or broken UI, right? You can have some type of asynchronous process that runs in the background. And when this worker is done, it could signal, Postgres and say, hey, we're also done. Update the status, which eventually the user would probably do a long polling or do some type of polling, or even WebSockets. If you want to make it nice, really nice user experience, you have a WebSocket event, go back and say your job is done. Well, let's talk about some of the main benefits of just this simple setup, right? First of all of your users' jobs are queued up in a queue, meaning A, they don't put a bunch of strain on your API. You have a way to throttle that, and typically the throttling is done by the amount of workers that you have. If you want to be able to scale up and handle more of this stuff, you can just go ahead and add more workers. Maybe during peak load, maybe at 12 o'clock at noon, you get the most load, and you can have it auto scaling based on time intervals to scale up 10 or 20 workers. They can all start pulling from the queue, doing the work, transcoding videos, etc. These could be lambdas, right? I've done this a lot in AWS where all these could be lambdas that just dynamically spin up to process these messages. You could use AWS Fargate. There are a ton of ways to scale out work and then scale it back down to save you on costs. But the idea is that you have this fleet of workers that can just, with a click of a button, basically process a ton of messages out of the box and then get all the work done. Okay. Now, another great thing is, let's say that the event goes to the worker, and then for some reason the video is just too large and the worker just crashes, right? It just crashes and you basically lose that processing for 1080p. The great thing about a queue is that since the worker never sent back that done message to the queue, this event still stays here, right? RabbitMQ, ActiveMQ, they have a durability set up so they can persist the event. In the case that this thing fails, it's reliable and can be retried. Okay. So even if this worker goes down, or maybe this worker is working on it, it doesn't matter, because now this event will get picked up eventually by a different worker, and that will get worked on and then eventually finished. Now, another cool thing with queues is that you can have something called a dead letter queue. So typically in AWS, when I've used SQS, you can have a queue send failed events to something called a dead letter queue. And what this allows you to do is, like, let's say you put a max retry of 3. So if this event fails and then it gets retried by another worker and it fails, and then it fails for a third time, there's something wrong with this message. For some reason, you just cannot process it. And so this gets sent to another queue where you can have another worker be configured to pull from the dead letter queue and do a different type of work. Maybe you can have an AI agent pull the event, pull the data, try to debug what's wrong with this video, and then you can have that send off into logs somewhere so that we can actually figure out what's going on with this event. Okay, because we had all these different things not able to process it. Or you could have it send out an event in Slack or an event in email to your developers so they can figure out what's going on with this thing. So that's another really beneficial part about having queues, is that when stuff doesn't work, you can have other processes kick off to try to get it done, or to triage what's going on. Okay. Now, like I mentioned, the message broker itself can have durability set up. So if something were to go wrong with the actual Redis instance and it goes down, the stuff can be persisted to disk so that when it comes back online, all these messages still exist. Now, there are trade-offs with this. If you have durability set up, obviously it's going to take more time for the message broker to write to disk to make sure that it doesn't lose this data. So you can't have as high as throughput versus if you just have an all in-memory queue, but it really depends on your use case. Maybe there's some events where you can lose them. It doesn't matter if the queue goes down. You can lose your events. You don't care. But in most of the situations I've worked on, you probably want to keep track of those queues. Now, I am trying to keep my videos kind of short with these architecture overviews, but I want to give one more useful key point of why you may want to use a queue in your software system. And it helps with decoupling, right? Instead of the API being coupled to FFmpeg in this whole message processing, video processing workflow, it's decoupled now. It doesn't have to worry about FFmpeg at all. All it needs to know is, hey, I just need to send out a video ID. That's it. And so later on, you can have a different service act as the client who sends off these messages to the queue. Maybe that could be a CLI tool. Maybe you can set up some type of testing infrastructure just with a script to send off messages to this queue, right? You've decoupled how the work gets done from the API itself. This can be invoked by anything that can just know how to send a message. Also, the thing that does the work can be completely decoupled as well. So now you can start adding different types of workers, and those workers potentially could be geared for specific types of work. So you could have a type is 2, and this could be a worker that does type 2 of work. So it's going to be grabbing from a queue of type 2 instead of the type 1 work, so that you can actually fan off work to different types of workers. Now, there's also something called a topic. I'm not going to get into topics in this video, but you can have events basically broadcast to all workers at the same time, and the workers can determine what they actually want to work on, right? So you could have a topic send off the same event to many workers, but that's a different use case. I'm not going to dive into that, but hopefully you guys enjoyed this little overview of queues and how they could be potentially useful. Let me know if you want me to dive into more details or more examples of this, but I do think this is a quick overview that can help you get exposed to the key terms that are needed for building out decoupled asynchronous workers using queues. Other than that, I guess have a good day and happy coding.